So section 1.3 is on
Is it 31?
huh?
Is it 31, page 31?
Yes, that's where the assignment will be. Actually, it will be page not 31, but 27. Okay, so what we're looking at is some what they call law of exponents. So if we're multiplying these two things together, they have the same base. So if we expand this out, this becomes x 3 times, written down 3 times. And this one is x written down 5 times. And then we're multiplying between those two. So how many times do we have our x's written down there?
In both combined?
Yep.
Or 2, 3, 4, 5, 6, 7, 8.
8 times. So what do you think when we're multiplying between things? What do you think we do with these exponents to get our final exponent?
Wait, can you say that again, please?
What do you do with these exponents to get this final exponent of 8?
Do you multiply them or add them?
Well, what did you just do down here? You went 5.
And then 3, so you add them?
You add them. Yep. So you add your exponents. And then, so when you're multiplying, you add your exponents. That is one of the law of exponents that we're going to use. But it's only when you have like basis. So if I had something like this, 3 squared times x squared times y to the 5th, that times x y to the 4th, we'd look and we see, okay, this is our base and it's squared. There's no other base of that same number over here. So our answer gets written down with 3 squared. We have this base now of y. We have an exponent of 2. And what's the exponent on this one when we see it there?
Would it be 2?
How about just 1 for this one? So we have x squared and x to the 1st. So we're going to take those two numbers and add them together to get x to the 3rd.
Okay.
And then our y has a power of 5 and a power of 4. So when we add them together, we get the power of 9.
Okay.
So you take each individual base, but you're looking for bases that are the same, and then you're doing that. So when we multiply, we add the exponents. What happens if we want to divide? What do you think we're going to do with the exponents?
Would you divide the exponents or multiply them? I don't know. Okay,
so here we were multiplying and we added. Now we're dividing, so we're going to subtract. Yep. So our final answer is going to be x to the 7th. 10 minus 3. And the reason why that works is if you think about expanding out that x to the 10th, you have 10 of these little x's up there on top. And then on the bottom, we have 3 of the x's. And we know that from the top to the bottom of a fraction, we can cancel out like things. So we cancel out one of those with one of these. We cancel out one of those with one of these, and one of those with one of these. And we're left with 7 x's on top. So those are the two concepts that we're using today. So when we multiply, we add exponents. And when we divide, we subtract exponents. Okay. So let's look at a few more examples here. My things run down. 12w to the 5th divided by 2w. Now the ones that are common bases are the w's. Anytime you see a w without a number in front of it or behind it as an exponent, put a 1 there. It's always going to be a 1 if you see that letter. So we have w to the 5th divided by w to the 1st. So 5 minus 1
It's 4.
Is going to give us w to the 4th. Now the numbers work exactly the same way as normal numbers work. 12 divided by 2 is 6. So 12w to the 5th divided by 2w is going to equal 6w to the 4th. Okay, just like variables, if you see a number that doesn't have an exponent on it, put the exponent of 1 there so you keep track of it.
Okay.
So if -2 is a base, what exponent is -2 going to have in our final answer?
Would it have 1? Because there's only 1, 2 there.
Okay. What's the exponent on this one?
5.
5. And what's the one on this one?
2.
2. So go.
It'd be 3.
It would be 3, yeah. So then move on to the base of 3. What do you see on the top?
4, then 11. So would it be?
Actually, 7. It's just a 1.
Oh.
It's just a 1 there.
So 3.
3. And then the base of 5.
3 again.
Mm-hmm. So that would be your final answer. Okay, so multiplying, you add, let's go through another multiplication one. A couple more. -2m times -8m to the 5th. So you have a plain number out here, right? Just a regular old number and a regular old number there. When you multiply them together, 2 and 8, what do you get?
16.
And because they're both negative, 2 negatives make a positive 16. So we've taken care of that part and this part. So now we just have the m's. Remember, whenever you see a variable with no exponent, put the 1 there. Now we're multiplying between this m to the 1st and m to the 5th. So what are we going to do with those exponents?
You add them.
And we're going to get m to the 6th. So that's what you're doing today, is you're going back and forth between multiplying and dividing and trying to figure out what you're going to do with your exponents. And I would like you to leave your answer in this form, like this one. Just leave it just like that.
Okay.
Because I'm looking for that you're paying attention to those exponents more than simplifying down to a single number. Okay? Okay, so for your assignment then, you're going to do 1 through 10.
Okay.
Page 27. 1 through 10, and then on page 29, you're going to do 26 through 32.
Okay.
Okay?
Yep.
And that's it. And if you can get that done by tomorrow or tomorrow afternoon, that's what I would like to happen. So then you don't have to think about math at all for the whole Thanksgiving weekend. You can come back on Monday and know that you're done already.
Okay. So today's the last school day for this week, correct?
It is.
And then tomorrow starts. Okay.
Yep. We do have a Google Meet at 11 o'clock for religion.
Okay.
Okay. So we'll see you there.
Okay.
All right. Thanks.
Thank you.
Yep. Bye-bye.